Welcome, everyone. Today, we are diving deep into the planning phase of the information systems audit process. Specifically, we will unpack the critical types of controls you must evaluate and the key considerations that shape a successful audit strategy. Let's get started. Let's begin with the foundation. Audit planning isn't just about scheduling meetings, it's the strategic backbone of your engagement. First, we define what we are doing, creating a roadmap that aligns with professional standards like ITAF. Why do we do this? Simple efficiency and effectiveness. You have limited time and resources, so you must focus on what matters most: risk. How do we start? We look at the big picture, the audit charter and the organization's mission. In our deep dive, remember that planning is dynamic. As you learn more about the business environment and its inherent risks, your plan must adapt to ensure you are auditing the right things at the right time. Look at this workflow. We start at the top with the audit charter, which gives us the authority to act. This flows directly into our planning process. The core engine here is the risk assessment decision diamond. Notice how it splits our path. High-risk areas trigger a concentration of resources and deep testing, while low-risk areas might only require minimal checks. Both paths converge to form the final audit plan and program, ensuring our strategy is directly driven by risk exposure. Now let's talk about your license to operate, the audit charter. Think of this as your badge of authority. Without it, you are just a visitor asking difficult questions. The charter defines the what, your scope, and objectives. It sets the boundaries so you don't wander into areas irrelevant to your mission, preventing the dreaded scope creep. Why is this crucial? Because when push comes to shove, you need executive backing. How is it formalized? It must be signed off by the board or audit committee. In our deep dive, realize that this document protects your independence. It clarifies that you are there to verify and assure, not to fix or implement, which ensures you remain an objective observer. This diagram illustrates the flow of authority. It begins with the audit committee, the governing body that approves the charter. From the charter, three critical pillars emerge: authority, responsibility, and accountability. Authority grants you the specific right to access records and systems. Responsibility mandates that you report your findings accurately. Accountability ties you to professional standards, ensuring that while you have power, you are also held to the highest ethical benchmarks. Moving on to the core logic of modern auditing, risk-based planning. We don't audit everything, we audit what matters. The formula you see on the screen is your mantra. Audit risk equals inherent risk times control risk times detection risk. Why use this? Because we need to provide assurance on the material items, the things that could break the business. How do we apply it? We score areas based on complexity and impact. In the deep dive, distinguish these three. Inherent risk is the beast in the wild, the natural risk of the activity. Control risk is the cage failing, management's defenses not working. Detection risk is us missing the beast, the auditor failing to spot the issue. Visualizing the audit risk model helps us balance our efforts. At the top is the audit risk we are trying to manage. It breaks down into three components. First, inherent risk, driven by factors like business volatility. Second, control risk, stemming from potential failures in internal defenses. And third, detection risk, which is the only one we directly control through our testing procedures. All three feed into the total risk profile, which ultimately dictates how much evidence we need to gather. Now let's categorize the tools we are auditing. Internal controls. We classify these by their nature. First, administrative controls. These are the soft controls like policies, background checks, and training. They tell people what to do. Second, physical controls, the hard barriers like locks, guards, and fire suppression systems protecting the data center. Third, technical or logical controls. These exist in the bits and bytes like passwords, encryption, and firewalls. The deep dive takeaway here is interdependence. You cannot rely on just one. Strong encryption, technical, fails if a user writes the password on a sticky note. Administrative failure, or if someone steals the server, physical failure. Here we see the hierarchy of control categories. The internal controls node branches into our three main types: administrative, physical, and technical. Look at the specific examples. Policies under administrative, locks under physical, and firewalls under technical. Crucially, notice the dotted lines. Administrative policies govern how technical controls are configured, and physical controls protect the hardware running those technical controls. They function as an integrated ecosystem, not silos. We just looked at the nature of controls. Now let's look at their function, specifically when they operate. First, preventive controls. These are your shield, they stop the bad thing from happening. Think firewalls or segregation of duties. Second, detective controls. These are your alarm systems, they tell you something went wrong. Think log reviews or CCTV. Third, corrective controls. These are your repair kits, they get you back up and running like data backups. How do we audit this? We prefer prevention, but we must have detection. In the deep dive, remember, if you can't prevent it, you must detect it fast enough to correct it before the damage is permanent. This sequence diagram shows the timeline of an attack. The threat attempts an attack against the preventive control. Ideally, the top path is taken, access denied. However, if the control is bypassed, the else condition, the breach hits the asset. Immediately, the asset generates a log for the detective control. The detective control then signals the corrective control, which jumps into action to restore or fix the asset. This visualizes exactly why layers are necessary. When one fails, the next takes over. Beyond the big three, we have advanced control types you need to recognize. Deterrent controls don't physically stop anyone, but they psychologically discourage bad behavior, like a camera's recording sign. Then we have compensating controls. This is huge for auditors. Sometimes a company can't afford a primary control, or they are too small for segregation of duties. A compensating control, like a manager reviewing logs daily, bridges that gap. Finally, recovery controls are specialized corrective controls focused on bringing systems back online, like a disaster recovery site. Deep dive takeaway. If you see a compensating control, your job is to test if it truly equals the strength of the control it replaces. This diagram helps you decide which control fits. We start with a risk scenario. We ask, is the primary control feasible? If yes, we implement it and the risk is mitigated. But if no, perhaps due to budget or staff size, we branch to the compensating control like manager reviews. Notice that both paths lead to risk mitigated. The destination is the same, just the route differs. At the bottom, we see the separate path for the human factor, where deterrent controls create a psychological barrier to reduce the likelihood of an event. We also classify controls by their scope. General versus application. General IT controls, or GITCs, are pervasive. They apply to everything. Think physical security of the data center or the change management process. If these fail, everything built on top of them is shaky. Application controls are specific. They live inside the software code, validating that an input is a number, not text, or ensuring a calculation is correct. The relationship is foundational. If your general controls, like access to the code, are weak, a hacker can simply turn off the application controls. In the deep dive, remember the input process output cycle. Garbage in, garbage out unless input controls stop it. This block diagram visualizes the dependency. At the bottom, in pink, is the general control layer foundation. Change management, logical access, and physical security. These support the application layer above. Notice the arrows pointing up. Change management ensures the input controls aren't tampered with. Logical access protects the processing logic. Physical security protects the output devices. The general layer literally holds up the application layer. We conclude with the critical considerations for the auditor. First, materiality. In is auditing, this isn't just money, it's impact. Could this control failure shut down the factory or leak customer data? Second, irregularities. While management owns prevention, you must assess the risk of fraud and illegal acts. You are the watchdog. Finally, evidence. It's not enough to think something is true. Your evidence must be sufficient and reliable. If you didn't document it, you didn't audit it. Effective planning brings all this together, risk, controls, and evidence, to form a defensible audit opinion. This final flow shows the execution consideration. We start with the audit strategy. We filter everything through the lens of materiality. Does it matter? We evaluate the risk of irregularities. Then we gather evidence. The crucial check is the evidence quality diamond. Is it reliable? If yes, we proceed to form our opinion. If no, if the evidence is weak or circumstantial, we loop back for additional testing. We never move forward until the evidence is solid.